Sahan Fernando from St. Joseph First College, Venapur. My research is investigation of anti-cancer activity of bioactive compounds present on plants in Sri Lanka for estradiol synthesis pathway associated with breast cancer via in silico approach. Breast cancer is the most common cancer in females. Nearly 3,000 new cases are reported in Sri Lanka. Out of them, nearly 40% are hormone dependent. Estradiol is a leading factor that plays a key role in the initiation and progression of breast cancer. Enzymes such as estrogen sulfatase, aromatase, and 17-beta-HSD1 involved in the biosynthesis of estradiol. In my research, X-ray crystal structures of the enzymes estrogen sulfatase, aromatase, and 17-beta-HSD1 were downloaded from the protein data bank, and the ligands were extracted from the original protein ligand complex and used as the reference ligands. Initially, they were redocked to the respective protein targets with the master software, and the docking procedure was validated. The structures of 200 natural compounds were retrieved from the Sri Lankan Flora database, were screened against the identified common characteristics and the active groups of already found inhibitors for the selected enzyme targets. The selected structures were energy minimalized using macromodel module of Schrödinger suite, and one structure per molecule was generated using the Lick-Break module. The drug likeness of the selected compounds was checked by the quick-proof module, and those which were toxic were rejected, and those which showed better drug-like properties were shortlisted and subjected to SP docking. Out of them, 25 of the compounds with the best SP docking score were selected and subjected to XP docking. Out of them, the top 50% of the compounds with the best XP docking score were selected to carry out MMGBSA binding free energy change calculations. Then, the ligands which showed greater binding free energy change than the reference ligands were identified as the most successful immediate compounds for the relevant enzymes. Here are the results. In conclusion, out of the 200 compounds in endemic plants in Sri Lanka from Sri Lanka Flora database, only 9 serve the virtual and MMGBSA filters imposed on them. These 4, these 3, and these 2 were identified as the most potent inhibitory compounds for estrogen sulfatase, 17-beta-HSD1, and aromatase enzymes respectively. Out of the screened database of molecules, one molecule was identified as having significant inhibitory efficacy toward both enzymes aromatase and 17-beta-HSD1. So, these compounds can be taken for further in silico and in vitro studies and subsequently used as a possible therapeutic agents for treating hormone-dependent breast cancer.